Okay, so this is the homework for Paul McWhorter's Pico lesson number 10, in which we are trying to change the LED brightness using a potentiometer. For this one I've got the potentiometer set up to pin 28 and the LED I've got to pin 15. Ignore these cables, they're just because my breadboard has a gap in the middle, so I need to join the two halves together. Paul wanted the LED to be off when the potentiometer is to the left and full brightness when the potentiometer is to the right. So I've got the ground connected to the left and the 3 volts connected to the right pin on the potentiometer, and obviously a current limiting resistor onto the LED and back to ground. Okay, so we'll start the programming with from machine, and we'll import PWM because we're going to need that for setting the LED voltage. We'll have pin, and we'll have ADC for reading the potentiometer. And time, we'll also import sleep, although that may not actually be required later. As I said, we've got the pot pin on pin 28. The LED pin, LED pin is pin 15. My pot is the ADC pot pin. Then we're going to have an analog out, which is the PWM pin, the LED pin. Analog out, oops. Frequency, we'll have it at 1000. Analog out of duty, we'll start at 0, just so the light's off when we first start. Okay, now while true gives us the infinite loop, we're going to start with the pot value, which we'll read as an integer from my pot dot read say U 16. Close that. Now, one thing I found is that with the potentiometer, sometimes when you're at 0, it sometimes gives you a slightly lower number. Generally, my pot comes down to 272. This is my potentiometer formula calculator. So my pot generally comes down to 272, but occasionally it will drop down below that, so it might give a 240 or a similar sort of number. And when it does that, sometimes it will flash the LED. So I'm going to put a little if statement in there, such that if it does go below then it will keep the value at 272. And the LED output is what we've got to work out with this little formula here. So we know that the pot value is going to give us a reading of 272 to 65,535, but we actually want an output for the LED of something between 0 and 65,435. When we put those figures in there, we have this formula to put into the LED duty. So LED duty equals 65,535 divided by 65,262 multiplied by, let's get that out of the way so you can see it, multiplied by the pot value minus 272 times 65,535 divided by 65,262. And then we'll send that to the LED using analog out duty U16. Send the integer of LED duty. And then we'll sleep 0.1. Okay, let's give it a go. Fingers crossed, see what happens. Well, the LEDs come on, which is a good start. And if we turn it around to the left, then the LED fades down to nothing. And if we turn it around to the right, it gradually gets brighter until we reach full brightness at the right hand side. There we go, and then back down. And it gradually fades until it goes off. Okay. One thing Paul said is if we save this, to the Raspberry Pi Pico. Oops, let's just turn it off. Try again. If we save it to the Raspberry Pi Pico as main.py, you see I've now saved it as main.py. Then when we turn the Pico off, as soon as we turn it back on again, it should fire up and the LED should be come back on the same brightness and still be controllable without having to run the program again. There we go. Okay, thanks for watching, and see you again next week.